Hello, everyone. Welcome to the Azure Takeoff show. Today, we again have Ozgur. Ozgur, welcome to the show again. Do you want to reintroduce yourself one more time for our audience?
Sure, Tasvar. Thanks for having me, by the way. I'm Ozgur. I'm a cloud solutions architect here at Microsoft, and I'm looking after digital natives in Turkey.
Excellent.
That's me.
Thanks, Ozgur. So, I know that today we're going to talk about some of the updates of ML and Microsoft OpenAI and stuff. So, let's share your screen and let's go through it.
Cool. So, thanks everyone for watching this. So there has been quite a few updates in the last couple of months, along with the Microsoft events like Build in May and Inspire last month in July. So we want to give you a quick update without this backlog of things getting any larger. I hope you find the content useful. Uh, I'm not sure if we can go cover all this, but yeah, let's say we will start with the challenges we've observed with development with large language models in the last year, let's say. And then we will see how the newly announced services and capabilities on Azure help address these challenges. And there are always usability upgrades in terms of quota management, service limits management, and model updates, for example. So we will cover these and consumption model updates in the operational updates section.
Mhm.
And obviously, we won't have a Q&A
Mhm.
with this recording. So yeah, let's quickly start. So what I'm showing in the slide is the technology stack that has emerged during last year, more or less, for developing with large language models. And if we have spoken early this year, let's say in January, we would see Microsoft playing in the green block here by
Mhm.
serving OpenAI's advanced GPT models as Azure Cognitive Service APIs. And this has significantly changed, so we are now covering
Mhm.
more space in the tech stack. And if we just go through this quickly, what requirements has come along and necessitated these extra capabilities in the tech stack? First of all, there is a huge amount of activity going on with the open source space. And we know that every single generative AI use case requires probably its own model because there are usual trade-offs between model quality, total cost, and performance of your large language models, let's say.
Mhm.
And there are also anti-patterns when it comes to OpenAI usage. So let's say GPT-4 is a very advanced model. It has sparks of AGI, it shows sparks of AGI, some basic reasoning capabilities. But is it the best model for each and every use case? Probably not. And there are some non-natural language domains like non-English languages or domains where the jargon is quite heavy, like in medicine, medical domains, law, and finance,
Mhm.
where if an organization has quite a lot of amount of data, high quality data, they can fine tune one of these larger models that are coming along, and the evaluation results show that they approach capabilities of GPT-35 Turbo, which is the mostly used, most popular OpenAI model. And the open source capabilities actually cover quite a lot of space in the tech stack because you, first of all, need the data
Mhm.
pipelines to feed your training data, fine-tuning data, and then you need the compute infrastructure, probably on a managed machine learning service like Azure ML. And then once fine-tuned, you need to extra compute for deploying the model for inference and for evaluation of the model itself. Let's say
Mhm.
you would like to compare and contrast the model results with GPT-4, for example.
Mhm.
And so we will cover this. So we have some exciting news on this front. And moving on to vector stores. Vector stores are getting quite a lot of attention and traction as well. Mostly because in order to get the value out of your advanced language processing capabilities with models like GPT-4, you need to connect them to your data. And then there is a certain pipeline which we call the retrieval augmented pattern pipeline, where you vectorize the semantic core of your data so that it becomes usable by the language models, which are matrix operations require data in vector form most of the time. And while we are at this, so it's good to mention one further insight as to why generative AI has become so popular. So there appears to be two reasons. First one is that generative AI actually unlocks unstructured data that most organizations sit on, which is not usable by the classical machine learning patterns of today. So they make this data and the insights that can be drawn out of this data available for organizations, so that these insights can be used at every level in our organization, and making it a data-driven organization. So that's the first thing. I find this insight quite interesting. And the second one is, this is more like an observation, let's say. Classical ML was focusing on capabilities where humans by nature are quite capable of. Things like sensory motor skills or driving, like computer vision type of use cases with autonomous driving, where you can more or less get things running, but to address outlier use cases, you need to be spending a lot of resources to address for marginal gains in your model performance. So model more or less works, but if you want to replace a human, you need to be addressing like very infrequent accident use cases, in which case you need lots of more training data, and it increases the cost. And at some point, organizations just give up on these stuff because humans can already do them quite well. Right.
Exactly.
Please tell us your own views as well. That's one of these points.
No, I mean, it's just you've seen this many times in real life too, right? I mean, it's like sometimes it's costing you so much to fix a certain thing with technology, while a human can actually scan an item in a cashier way more faster, sort of thing. Do you understand?
Exactly.
Automating it.
So I don't know if this has any sort of specific naming for it, but this is the case we've observed with classical ML. But with generative AI, you can address use cases where humans struggle, like creative endeavors or large amounts of information that needs to be processed and needs to be brought together in new and creative ways. Which is the main use case for large language models, like generating language out of data. So while we're at the data integration piece, I wanted to mention these two driving forces behind generative AI traction. Cool. So vector stores are coming along, and we have new services on Azure that can satisfy the requirements there. And content security is always, responsible AI practices is always fundamental to generative AI deployments. We already have advanced capabilities on Azure OpenAI versions of the GPT models when compared to OpenAI, where things like offensive or hazardous content or biases are removed by filters with inline and offline models detecting these. And with this piece, what I'm trying to convey is that the control needs to be shifting towards the user as well, a bit, at least the developer, so that for certain use cases, let's say for entertainment use cases, you might have like looser filters. Whereas if you're deploying an enterprise use case, you might have stricter filters. So rather than relying single widget type of filtering here, this will enable the developer to customize the filtering level as per their requirements. And again, we have an announcement there. So on top of this, there's a tooling and development frameworks layer where LLM-specific tasks, for example, context management, context management in chat, or memory management in chat, or integration with vector stores again, can be done very quickly with simple method calls rather than developers writing code again and again to satisfy these requirements. So there are already quite popular open source frameworks appearing. LangChain and Llama Index are two examples. And Microsoft now has our own framework that's emerging here and getting traction. And in the LLM space, we have a very attractive offering now. And I will show the names of the services in the following slide. And I wanted to be more effective with the animation that I worked on, which was quite difficult to get it right. Sure. So this piece is about the experimentation required to get things working correctly with the probabilistic models, which we call LLMs. So like in classical ML, where you do experimentation management with the likes of MLflow, for example, you need to have tools to store, to first of all run these experiments and store them with their metadata to be recalled later, to be used or deployed for many other use cases. And I've already talked about data-driven organization concept, where each layer of the organization, data and insights that are extracted from this data are used in decision-making at all layers, which means non-technical people would also need to be able to build their own applications in a no-code manner. And we have, again, new offerings here, like of bring your own data service. And the Copilot motion is already progressing and expanding into many other Microsoft offerings like Office or Sales Accelerator are some of them where we have the models embedded into the SaaS offerings themselves. And on non-Microsoft area, we already have very successful startups like Midjourney, Runway ML. Midjourney is, I use it quite a lot. It's very impressive, to be honest. It's a text-to-image service. Runway ML is text-to-video, and Jasper is like a text writing assistance service, and it uses GPT models. Midjourney and Runway ML have their own models deployed, but these are SaaS services with generative AI models embedded into them. So with this, we capture the existing landscape for developing and deploying LLM apps for today. And after quickly going over the challenges, we will see how the new announcements help address these challenges. The first of these is the need for experimentation and the tooling that needs to support this experimentation piece. So these models are probabilistic. We don't have much control, let's say, on their generations. We don't really know how these models work. People, there are some good ways of explaining how this works. Some actually make it resemble like the physical phenomena. For example, water turning into ice below a certain temperature, it turns into ice, and it's very sudden. And with LLMs, what we think is after some certain point of scale, these LLMs start generating very impressive generations, but we don't know how they work. And now, like hyperparameter optimization in classical ML, the advanced hyperparameter that we try to optimize is the prompt. And again, prompts have lots of variants. They have their own hyperparameters like temperature, top K, top N. And we also have lots of models. We talked about open source motion.
Yeah.
And even if we don't embrace open source and we only confine ourselves with OpenAI's GPT models, they already have lots of variants. We used to have the March versions of models. We now have the June versions. We also have different context length versions of the same model. Like, for example, GPT-35 Turbo, by default, it has 4K context length. Now we have a 16K for context length version. Context length is the short-term memory, and it determines the amount of data that you can submit to the model along with your prompt. So if we say the context length is 4K, that's more or less 4 pages of text that we are talking about, and the total amount of your prompt and the generation that it will create shouldn't be exceeding 4,000 tokens, 4,096 to be precise. So yeah, the need for experimentation. So because they're probabilistic, we don't know how they work. The only method that we have is, again, empirical methods, trial and error. And the more you can try, the better results you will have. And do you have a tool to facilitate this experimentation process?
Okay. Yeah.
And yes, we have. And second is the open source models we talked about. This is progressing astonishingly fast. In July, Microsoft, along with Meta, announced Llama 2 as an open source model, and this will be embedded into Windows going forward as well. I don't know what specific use case it will address, like a personal assistant or something, but it's a very capable model, and when fine-tuned with the high-quality data, gives very good results. And this should be part of a generative AI strategy for any organization, especially for non-natural language use cases. And multimodal is again another challenge. GPT-4 is 17 to 20 times more expensive than GPT-35. So although it's very advanced, you can't use it for each and every use case. So usually you have an orchestrator which identifies the use case and forwards it to the right model. So we're progressing towards such an architecture.
Over here, you could technically use multiple models too, right? As in like together to formulate your solution. You could use 4 a bit and then use 3.5 and things.
Yeah, exactly. So, with the hype around generative AI, we're talking about many use cases, like because people think it's the answer to all the problems that we have currently. But the first thing we try to convey to our customers when we talk about GPT models and generative AI in general is, not every problem is suitable for generative AI. We already have very advanced and accurate models handling use cases like classification or regression use cases. And for example, sentiment analysis use case, it works with generative AI, but if you have like a huge spectrum of emotions, the results are inconsistent. And you will either try to handle this inconsistency, or you will the better and easier, probably cheaper way to do this is using a standard classifier model, deployed on Azure ML and add it into your pipeline with a simple model deployment URL, REST API, and API key. So we are seeing more and more of these more sophisticated pipelines for generative AI, where classical models, many different generative AI models, also from other vendors as well, and our customers keep exploring strengths and weaknesses of each models. So we leverage the whole space for that.
And
multimodal. Yeah.
As
Go on,
you
please.
as you put it, with leveraging, but also there's in the next part was more like service infrastructure. Basically, we see a lot of like integration at scale. Like, I mean, these models are huge, sort of thing too. And then like the service infrastructure needs to enlarge to actually support these too, right?
Yes, yes, definitely. So it serves infrastructure. My point here is that another constraint with working with generative AI models is they have some shortcomings that are coming in by definition. Let's say, for example, with GPT models, they are pre-trained transformer models. That means their training data has a cutoff date. For GPT models, this is September 2021. So
Mm-hmm.
if you ask anything to the model that happened after this date, they won't have an answer, or it will hallucinate if you didn't put proper controls around your system prompts.
Okay.
So that means you need to have a service infrastructure at the periphery, API integrations to your model, where you will address these shortcomings with these capabilities that you're integrating.
Mm-hmm.
For example, for this pre-trained pre-training cutoff date, you can have something like a SERP API, which can browse the internet and brings back the correct result to you.
Okay.
Or many models are not very good at arithmetic. There are many theories around why this is the case, but this is the fact. So a simple way to do this is just use a calculator, a calculator function, even with the new function calling feature of
Mm-hmm.
Azure OpenAI. And
Okay.
so there are so many of these, and this is an infrastructure that needs to be managed at scale. And there is also another concept called agency, where you don't uh, uh, prescriptively define each and every step of your application to the model and expect it to go through and execute each of them. But you put a declarative statement, like a general problem statement, and then the model goes back, strategizes over the problem, comes up with a plan, a set of tasks that needs to be executed to achieve the result that you're after. So this is the agency capability that is getting more and more traction as we
Mm-hmm.
go along. So this service infrastructure will enable things like agency, and again with, for example, prompt flow, which we'll talk about in a bit. I'm
Mm-hmm.
sure. I hope we have time. We will be able to address this. And vector indexes, we talked about content moderation, the requirement for control to shift towards the user is another thing that we covered, and LM-specific challenges that can be resolved by simple method calls, and the no-code motion, which lowers the technical barrier so that these capabilities can be leveraged by everyone across the
Mm-hmm.
organization.
Yeah. Sounds good.
Cool. So these are the challenges. The reliability bit, I will spare a minute for this because this is the most challenging thing for our customers, and we constantly get questions around this. And we already know the answer, but there is no answer to address this. But there are methods
Yeah.
to address them. I only included this to emphasize the need for experimentation at scale. Reliability brings in 5 other dimensions within it, which are, first of all, misinformation. That is, the training data for the LLMs already have factual, incorrect information in them. And models tend to amplify these inaccuracies, first of all. And secondly, for things that aren't very popular, facts that aren't repeated within the training data, researchers found out that LLMs tend to make incorrect generations when questions are asked for these rare, let's say, items within the trained data. Hallucinations is quite interesting because this happens even though when the trained data is correct, you get incorrect generations. and this is said to be resembling something called contrafibrillation in cognitive diseases, where a person makes up incorrect memories, like in the movie Total Recall.
Okay.
So hallucinations is also, we don't know why it happens, and we only have empirical results that helps alleviate them. Inconsistencies, we know. Yeah, sorry.
Would hallucination be part of something like manipulations too, in some ways? Like, I mean, as you put it, like some kind of a dream that you don't know of, but you think it's reality. But like, would prompt engineering kind of play into the hallucinations too, in some ways, as in like you're retraining them to like, 1+1 is 3 kind of thing? Like, would that make it
exactly.
hallucinate? Or?
1+1 equals 3 is the fifth one. Sycophant. Yeah, we will talk about this. It's quite interesting, as you said.
Yeah.
But what we observed, at least what the researchers concluded, is that the less aligned a model is, the more open it is to misuse. So what you're saying is trying to retrain the model or trying to extract the system prompt. These are types of adversarial attacks. And if reliability piece isn't handled correctly, the model becomes open to misuse. So this is called more or less misuse. For example, you can, with a properly engineered prompt, if the model isn't aligned properly, its controls aren't in place, you can create like a bad political propaganda with the model. That was one of the concerns with the initial DaVinci 02 models, ChatGPT-3. But then the team, OpenAI team, what they did was they came up with instruction tuning. So this is called supervised fine tuning, with like not very big amount of data, human generated system instructions. They train the data, then they do reward modeling, then do RLHF. And what turned out to be in the end is this current GPT-35 Turbo model, which is more aligned and less open to misuse. So yeah, this is what we already experienced, because DaVinci models had these problems in them. That's why they are now being discontinued. They are not really be living any longer. Let's put it that way.
Yeah.
Inconsistency, yeah, we already know about. Even if you change like a grammar sign within a sentence, the output changes. Miscalibration and sycophancy they are quite interesting. Miscalibration is when the model doesn't have enough information, it can behave as if it is an expert on the subject. So we know how we call these sort of friends of ours. But yeah, it is thought of being a side effect of RLHF, where you train the models to be helpful, honest, and friendly, and harmless. So this is 3H, and that somehow and makes the models to be miscalibrated. And sometimes what happens is this 1+1=3 case, even though a model comes up with the correct result, if you, the user, say that, okay, you're telling me that 1+1 is 2, but I think it's 3 actually. Then model says, yeah, it's actually a 3. I made a mistake, kind of thing. So it is prone to change its answers and make them incorrect, just to align with your user prompts. And again, this seems to be the side effect. And we have lots of prompt engineering methods. I'm not sure if we have enough time to go all over them, but
next time we can
maybe next time. Yeah, let's keep them for next time. But we have best practices, so you need to, just in a couple of sentences, you need to divide complex prompts into simpler prompts, and handhold them so that they stay on the subject. Want them to self-reflect and make the generations a bit slower, so that the model can have more compute cycles in the background, more inference time, and in that way you can push it to create more correct answers, which is quite interesting.
Hmm.
And we already have some documentation on Microsoft Learn on this, and this is a quick summary of this. And I'm skipping past these. Okay, so let's come to the animation. So okay, so now this is where we've come. We
Okay.
start with this little green piece. Now we cover the whole
Now
stack.
now I understand the drum roll, as in like the green just expanded pretty much to the whole entire
Yeah,
slide. Yeah.
yeah, exactly.
Yeah.
Which was really a pain to
Yeah.
make it work. And to go specifically over each and every service and capability. So with Azure ML model catalog, we now offer open source models, Llama 2 from Meta, as well as Azure ML curated models where you can fine tune and evaluate with GPU instances, and the OpenAI GPT models. I will. We can have a quick demo on this if you have time. And now Azure Cognitive Search Vector Store has vector capabilities as well. So you can create embeddings with GPT ADA 002 embedding model, for example, and then index them and store them on ACS to do things like similarity searches, like approximate nearest neighbor search algorithm, for example, works. And there are hybrid search options which increase the search performance as well. So we also have this capability. Now we have Azure Content Safety, which is a service that is to moderate generations by generative AI services in a multimodal manner, both for image and text for now, where you can create customized filters in 4 dimensions, like offensive content, sexual content, hazardous, and self-harm, I think were the dimensions there, and implement these customized filters as per your model deployment.
Okay.
So which is a new capability. We have semantic kernel, which supports C#, Python, and Java, and integrates these models into the rest of the Azure platform of services and helps you implement all these LLM-specific development tricks, let's say, in a much more efficient manner. We have prompt flow to support experimentation, as well as to manage the service infrastructure that I mentioned. And yeah, this is probably the best place to develop your LLM apps going forward, which brings together different frameworks, different Azure services, your vector stores, your code, and service infrastructure APIs, and also gives like a notebook type of experience for ML practitioners. They love that, and enables collaboration, pair programming, code sharing type of things. And we will hear more integrations on that front with developer tools and probably with GitHub as well.
So I also see that Copilot's on top, right? So have you played around with Copilot with like ML prompts? Like basically have Copilot to generate the ML prompts for you, like the level below it sort of thing, orchestration.
With Copilots, I'm a subscriber, pay my $10 every month, and I'm very happy with the service. But the way I generate my prompts is with prompt flow. I actually didn't think about using Copilot for that. With prompt flow, what you can do is you can generate your prompt variants with the GPT models. So you can use one of your prompts as your template, and then you can have a quick look if you have time. Then you can ask for prompt flow to generate like 4 or 5 more variants based on your template using the GPT model. But that's a very good question, because I think going forward, GitHub integration with LLM app development and leveraging GitHub Copilot capabilities will be on the forefront, especially when you talk about experimentation management and storing and cataloging your development artifacts, like
Mhm.
prompt variants is one of them, along with the experimentation metadata, the
Mhm.
performance, the accuracy, F1 accuracy type of things. There will be more integrations, although by itself, I think it's quite impressive. Prompt flow is. So yeah, again, we'll probably need to repeat the session.
We could have a session on like prompt flow, basically. Let's
Yeah,
plan
we
that.
can deep dive on this.
Yeah.
Maybe I'm not sure if we have time left to go a bit deeper on this, but um, so yeah, this is where I tried to explain. So if you're leaving the demos for another session, let's maybe
Mhm.
close with a couple more slides and show our viewers how sophisticated things are getting and why we actually need these sort of capabilities and tools. This is actually an application
Mhm.
that is a customer of ours who made it to US productivity charts, top 10, millions of downloads per month, and which
Okay.
was basically a wrapper around Azure OpenAI with a
Mhm.
simple backend that's running on Azure functions.
Yeah.
Uh, and now what we see is more of this, more like this,
Okay.
where we need to put semantic filters
Hmm.
to make sure, for example, if we have a customer who is developing a chatbot to suggest to aid shopping for food, let's say groceries,
Yeah.
and what happens if you go there and ask how large language models work? You need to have like a semantic filter to understand, for the application to understand that the question isn't related with the use case being deployed, so it doesn't
Okay.
become an open attack vector for
Hmm.
people to use ChatGPT for free, for example.
Hmm.
Or let's say if you have many models, how do you route the correct prompts to the correct models in that manner? We talked about agency,
Hmm.
uh, and there's another piece, for example, that's emerging called LLM cache.
Okay.
Cost optimization is becoming an
Hmm.
issue these
Yeah.
days.
Hmm.
And do you go to the model for each and every prompt, or is it better to check some sort of cache, do some semantic similarity search, and see if a similar prompt was already submitted to the model and its generation was cached, so that you can just grab
Reuse
this
it. Yeah.
response and
Yeah.
reuse it, right?
So I also
Uh,
see this as a natural progression of things too. Like I mean, if I look at technology in a different way, you remember how the serverless or functions came out first, as in like you could just call this thing, and then like you could just use it as small little things. You could query it and get back sort of thing. This I see is more like almost like Kubernetes kind of thing, where you like all of a sudden it's like have all of these. The natural progression of things like required more little microservices to do certain things, and then
exactly.
integrates into this holistic way of like answering your things. You put the caching, I see a logging over there, so it's just a natural progression of like technology stack, I would say. I know it looks way more complicated than the previous one, but I think this is just a natural flow of things where now people are asking way more complicated things, and people are asking or you need to scrutinize it a bit more, have some more logging so they could learn from it, and how do you optimize it by using some caches and
Yeah,
things.
yeah, exactly. And as technical technologists, we embrace complexity. We thrive on it, right? So, so we try to make things complex. But yeah, joking aside, the services that we see coming out
Mm,
as additional capabilities for Azure ML are actually targeting to simplify things and come up with
mm,
a comprehensive environment that addresses all these requirements.
mm,
Probably introduce them to your pipeline, which is
mm,
called flow
mm,
in prompt flow
mm,
terminology, let's say,
mm,
as simply like a building block being added to a cascade of other blocks as a
mm,
pipeline.
mm,
Uh, and yeah, although the requirements are getting quite sophisticated, we're trying to simplify things and make it easier for developers to be developing on Azure with LLMs. Okay, so going back to our technology stack slide, we more or less covered these capabilities. And what we can do is we can, in another recording probably, we can deep dive on these capabilities with model catalog, how you can one-click deploy an open source model to Azure ML, and then use it in your LLM pipeline as any other GPT model, for example. And we can do that on prompt flow, which gives you a very nice GUI, a practical interface where you can integrate all these models as well as the service capabilities with service integrations. And what generally comes across as a good demo is integrating it with ACS vector store and demonstrating how easy it is actually to create a vector index out of your data and then create an application where you can query your data with a chatbot experience and one-click deploy it again as a compute service on Azure.
Great. Thank you, Ozgur. Like, I'm really excited about the demo. In our next episode, we're going to go through all of this stuff. I'm totally excited for it. Again, thank you so much, Ozgur. I learned quite a lot.
Thanks for having me. That's right.
Yeah, thank you so much. So I'll see you in the next episode. I'm really excited.
Yeah, thanks. That's why I'm looking forward to it too.
Yeah. Okay, take care. Bye.
Thank you. Bye.